Hello and welcome friends in this particular module. In this module, I am going to discuss about simple differential fly and check leveling. Even the methods in order to reduce the levels are also discussed. If the student is new to this particular presentation, my sincere request is go through module 2B available on my channel prior to entering into this particular module. As student learns the content, one will be able to classify the leveling works in land surveying, entering the readings in the leveling page of field book and compute the reduced level by rise and fall as well as height of instrument method. One will also able to solve simple numerical problems based on this RL computation. So principally, there are two classes of leveling. First one is indirect leveling and second one is direct leveling. Here, this indirect leveling is more relies on trigonometrical concepts. So to say, the equipment or rather a variety of the equipment used during the land surveying operation help us to record the vertical angles as well as these particular horizontal distances. So by making use of these particular angular dimensions as well as these particular horizontal distances, one can calculate the reduced level. Hence, it is termed as trigonometrical leveling. Even parametric leveling is another branch which makes use of phenomenon that difference in elevation between 2 points is proportional to difference in atmospheric pressures at that points. Therefore, a barometer can be used to read at different points to know the relative elevations of these points. But at a given point, the atmospheric pressure does not remain constant in the course of the day, even the course of an hour. Hence, this method is quite inaccurate. The third category is hyposometry. Here, the way we consider the use of atmospheric pressure in order to understand the difference in reduced level, one can make use of boiling point of water. The popular phenomenon is boiling point of the water decreases as the pressure decreases. Here, let me make clear that as far as engineering concepts are concerned, though we have considered these as one of the categories, especially barometric leveling and hyposometry, it is not useful for engineering works. We definitely can employ this particular trigonometrical leveling, and I'll be discussing this as you get acquainted with theodolite operations in our subsequent presentations. Now, the remaining part of this particular presentation is simply concentrating on this direct leveling, which is nothing but spirit leveling. So in this direct leveling, elevations of the different points are determined with respect to the horizontal line. Here, as I referred earlier, you must know exactly what do you mean by horizontal line. Just to have the brief recap, we consider a level surface which is parallel to the mean spiral surface of the earth. We consider the plane which is tangential to that particular level surface, and that horizontal plane defines the position of horizontal line. Any plane which is perpendicular to the vertical, in the vertical direction, is vertical plane. So, in order to define this particular horizontal line, we make use of longitudinal level tube as we discussed in the construction while discussing the constructional aspect of dumbbell level. So, in spirit leveling, we make use of this particular spirit level as sighting device, which is nothing but the telescope, are combined, and vertical distances are measured by using the graduated star, again of variety of the categories. This kind of leveling is commonly used in all engineering surveying operations. There are many classes as far as this particular direct leveling is concerned: simple leveling, differential leveling, fly leveling, check leveling, profile leveling, cross leveling, reciprocal leveling, and precise leveling. Here in this particular presentation, we'll be discussing the 4 categories, and in our subsequent presentation, we'll get more acquainted with the remaining classes. So, simple leveling, the way name suggests, it is the simplest process in the leveling. Here, the equipment is placed in between the 2 given stations, and here we take the reading with respect to the various star, and we wish to determine the reduced level of say point A and some benchmark, the way it is presented here. So in simple leveling, just we deal with 2 stations. Whereas whenever the 2 points are placed at quite a distance apart, or if the elevation difference in between these stations is considerable, we have to go for differential leveling. Here, there is no necessity of alignment of the stations in between the starting station and ending station. Our primary aim is to determine the difference in reduced levels of the stations under consideration. The fly leveling is another category of leveling. It is an operation of the leveling in which the line of level is run to determine approximate elevations during reconnaissance of surveying operations. As we discussed previously, reconnaissance is the preliminary step as far as land surveying is concerned. So, during the reconnaissance, we are to understand exactly with what kind of elevational differences we could be dealing in the detailed surveys. So for that, we carry out the fly leveling. Here, we do not take any intermediate site, but we simply concentrate on back side and fore side, because the intermediate terrain we do not much bother about, but we wish to have the difference in elevation in the first station and last station. So the way this particular sketch is showing, we wish to determine the bearing of the last station, the reduced level of this particular station P with respect to this particular benchmark. So we have taken the number of change points in between, and accordingly we have not taken any intermediate site. One must understand one more concept that we will be discussing again in the subsequent slide, that don't get confused about this particular determination of approximate elevations. Sometimes, say for example, if we are carrying out some kind of leveling operation and the GTS benchmark is placed quite a distance away, and if we wish to carry the reduced level of that particular GTS benchmark up to the site where we wish to work, So at that time also fly leveling can be conducted. Even the similar operation can be had in order to apply the check on various works. Hence, fly leveling is useful operation at all the stages and for all the categories of constructional activities. Here, say we started our leveling work from station A, say with respect to certain benchmark. The blue triangles represent the instrument station 1, instrument station 2, 3, 4 and accordingly. Now at the end of the work, as we close the work at station E, now we wish to know whether the leveling works that we have carried out over the run that we have considered here is correct or not. So at the end of the day or at the end of the work, from the last station, from the last instrument station, we can just reverse the work order. We can follow entirely different path to reach the starting station. Here again we can adopt the fly leveling. Intermediate stations can be totally made obsolete as such. Hence, as the computed value and the value from what we started the work should be lying within the permissible limits, which is nothing but the closing error. You know that this particular closing error can be expressed as easily equal to C root K, where this particular C parameter varies according to the category of the works, and K is the distance traveled by surveying equipment in kilometers as such. So in general, this particular check leveling is the type of leveling carried out to check the elevations which are determined already. It is usually carried out at the end of the day from last station to first station of the work. One more thing is, say if you have certain benchmark such as BM3, BM2, etc., of which the reduced level with reference to the work that we have carried out is already in our hand. Hence, instead of going to the starting station, we can determine, or rather we can redetermine the reduced level of BM3 and BM2. Again, the value that we have and the value that we determine with respect to RL of last station should be in close agreement with each other. As such, as the name suggests, check leveling is nothing but the category of the leveling which applies check on the kind of leveling work that we did. As we observe the readings as backside, intermediate side, foresight with respect to some benchmark, the next task that we wish to have is determination of reduced level. So as discussed previously, reduced level is nothing but the height or depth of that particular point above or below the reference plane, which is called as datum. During this particular reducing level operation, we wish to know about that particular height of instrument, which is nothing but RL, or elevation of line of collimation with respect to that particular datum. So by making use of these two, we can have either collimation or height of instrument method or rise and fall method in order to determine the reduce levels of the various stations that have been included in the scope of leveling work. More about this in subsequent slides. So first slide, it is telling us about the height of instrument method, or it is also called as collimation of plane method. So in this method, height of instrument is calculated for each setting of the equipment by adding the back side to elevation of the benchmark or the previous point on which the reading was taken just before shifting the equipment. Subsequently, all the elevations are determined by deducting the readings that we take from the brace setup. As we compute the reduced levels, here at the end we apply the arithmetical checks as summation of backside minus summation of foresight should be equal to last computed RL minus first RL from where we started our computations. See here, this is telling us that we started our work from A, we ended work on D. So, having first reading taken as 0.9 meter with the first setup of the equipment, 0.9 meter is entered as backside reading. After taking this particular backside reading, on station B, we have taken the reading of 1.1 meter. Hence, it is entered as intermediate site. Now, from this particular setup, the reading read on station C, which is 1.05 meter, is last reading. Hence, that particular reading is treated as foresight reading. Now, as we shift the equipment, here this is instrument station 2, and on station C itself, again we take the reading as backside reading. So, on station C, we have taken foresight reading from the first setup and backside reading from the subsequent setup. Hence, station C become change point here. Again, on station D, the reading read 1.55 is last reading, and that's why it is entered as foresight reading here. So I hope how we enter the reading is clear here. Now, actually we calculate this particular HI with respect to datum. So HI in simpler terms is nothing but reduced level of line of sight, and that reduced level should have been measured with respect to the datum under consideration. So here first station A is nothing but benchmark, which has reduced level of 100 meters. That means with respect to datum, the vertical ordinate is of 100 meters. In order to have the RL of this particular line of sight determined, which is nothing but the HI, we have to add that particular backside in that. Hence, here that 100 benchmark plus 0.9 meter, which is nothing but 100.9 meter, and hence the HI worked out is 100.9 meters. Now, up to this particular line of sight, the reduced level is of 100.9 meters. Now we wish to determine the RL of station P, which is nothing but the vertical ordinate with respect to datum up to that particular station P itself. That means the reading above the ground up to that particular line of sight must be deducted. So 100.9 minus 1.1 meter is 99.8 meters. Similarly, 100.9 minus 1.05, which is nothing but 99.85 meters. Now, this is the change point. There are two readings, 1.05 and 1.45. So, the line of sight RL is changed, its height is changed. Hence, we have to work out this particular HI afresh. In order to determine that, here you have the previous RL 99.85. As you add 1.45 into that, you will get newly established height of instrument. Hence, as we deduct the last site which is taken on that particular last station, you will be able to work out the reduced level of last station. Now, as we discussed previously, we have to apply the arithmetical checks as summation of backside minus summation of foresight. So here summation of backside comes to be 2.35, summation of foresight comes to be 2.60. As we determine the difference, it comes to be minus 0.25. Similarly, 99.75 minus 100 also comes to be minus 0.25. Hence, all the calculations that we have performed are correct. Please note one thing. These arithmetical checks, the way it suggests, is meant for applying check for all the calculations that we do. It has to do nothing with the degree of accuracy or kind of field work that is involved in leveling operations. Now, the second method is rise and fall method. It consists of determining the difference of the levels between two consecutive points by comparing their start readings. The rise and fall thus often is used to work out the reduced level of subsequent station. So, if the subsequent reading taken is less, there has to be rise. Being rise, it has to be added in the previous RL. If the reading is more as compared to just previous one, there has to be fall. So being fall, it would be treated as a negative, and the fall would be deducted from the RL of previous station. Here, after performing all the calculations, the way we applied the arithmetical check earlier, as summation of backside minus summation of foresight should be equal to last RL minus first RL. In rise and fall method, will be involving one more check, which is nothing but rise minus falls. So here, summation of rise minus summation of falls should be tallied with the last RL minus first RL as well as summation of backside minus summation of foresight. Here, again, we will take the same problem in order to bring the clarity in the concepts. I hope there should not be any problem as far as the data entry is concerned. As we discussed previously, first RL is given as 100. See now, for the first instrument station, first reading taken is 0.9 meter. As compared to 0.9 meter, reading taken subsequently is 1.1 meter. That means here, being this reading more, there has to be fall. As we work out the difference, it comes to be 0.2 meter, and here it is entered as fall. Now, as we discussed previously, being fall, it should be treated as negative and it should be deducted from the previous RL. So 100 minus 0.2, which is nothing but the 99.8, which is RL of station B. Now, on station C, here we have worked out the reading as 1.05. This is the change point. Hence, after shifting the equipment, again we have taken the reading 1.45. As 1.45 as well as 1.05 both taken on the same station, there cannot be rise and or fall with the same entity. Whereas, as we shifted the equipment and as we maintained our continuity by taking this particular foresight as well as backside, we have taken the subsequent reading as 1.55. Hence, from the same setup, 1.45 and 1.55 are taken. So that's why as we compare these, here we get fall of 0.1 meter. Being fall, it should be deducted from the previous RL. As such, the reduced level can be worked out as the computed value shown here. Now, the way we discussed about arithmetical checks, summation of backside minus summation of foresight, summation of rise minus summation of falls should be equal to last RL minus first RL, and here the computation shows the value is minus 0.25. Hence, all the calculations that we have performed are correct one. So as you see, the RL of these particular stations can be worked out by the plane of collimation method or HI method and rise and fall method. Comparatively, plane of collimation method is rapid and simple. There are not much calculations. Whereas, in rise and fall method, calculations are complex and hence it takes more time. The involvement of the checks as shown in the problem, it is very clear. Worth understanding is third point. See here what is happening. We are checking simply the last RL and first RL difference. Hence, there is no check on RL of intermediate stations. So, if we perform any mistake in the computation of intermediate values, all the calculations will go as it is and the mistake that has been committed will not be detected anywhere. Whereas in rise and fall method, the way you see, we are using this particular check, summation of rise minus summation of falls, and we are comparing with these two remaining checks. Hence, every intermediate check is being checked. So, even if we commit some mistake while working out the reduced level, it will always be detected. So, if we are dealing with certain simpler works like longitudinal leveling, cross-sectioning, contouring, etc., HI method can easily be used. Whereas, if we are going for check surveys, if we are making use of certain ply leveling in order to transfer the reduced level from known benchmark to benchmark which is to be set, we go for rise and fall method. One more important thing is, always all the staff readings that we wish to take won't be remaining in the range of that particular entire staff. Popularly, we go for turning points or change point in order to continue our work from instrument station to instrument station. Still, it is quite probable that some stations are placed so high that even the staff, which is mostly 5 meter high, won't giving the desired reading as such. So here, what happens is, we go for certain inverted stuff. Try to understand, here there is certain girder. So, instead of keeping 0 of the staff on the ground, now that particular 0 of the staff is kept flushing with that particular girder. Hence, now this particular staff is just in its inverted position. Now, as we see, this is our instrument station. After carrying out the temporary adjustments, we have taken the reading on the benchmark having reduced level of 50 meters. The actual staff reading is 2.24 meters. Hence, the HI, the way we considered, has to be 50 plus 2.24, that is 52.24 meters. Now, as we discussed previously, we have to deduct all the readings taken subsequently in order to determine the reduced level. But here, as you see, we have inverted that particular position of the staff. We have kept the 0 of that particular staff flushing with this particular bottom of the girder. That means we have to treat this particular inverted staff reading as a negative. So 52.24 minus into bracket minus 4.27 bracket complete, which comes to be 52.24 plus 4.27. Hence the reduced level of that particular point is 56.51. It is quite easy to understand. Again, with reference to the blue line and red line I have shown here, all the reduced levels have to be expressed with respect to datum. Being RL 50 meter, benchmark is set at 50 meters above with respect to datum. 52.24 meter is HI, that is the vertical ordinate in between the horizontal line representing line of sight and the datum is of 52.24 meters. In the similar manner, here up to this height is 52.24 meter, whereas RL of this will be nothing but this particular entire red line height. Hence 52.24 plus 4.27 should be equal to the reduced level of that particular girder. I hope the concept is clearer. This particular concept is very useful when we set benchmarks or when we have to determine the reduced level of certain constructional elements, or when we wish to set some rooftops or ties of the trusses or lintels. We can make use of this particular concept easily. Let's try to attempt one more problem. So here the following staff readings were observed successively with a level and the staff which is having height of 5 meter. So instrument is moved after 3rd, 6th and 8th reading. Now the way you see, as we have taken the readings successively, there has to be some fixed relationship in the data. Say for example, if we are working on continuously sloping ground, the reading should go on increasing continuously. If we are working on continuously rising ground, the reading should go on decreasing continuously. But the way you see here, that if there is certain abrupt change in the readings, it indicates the change point. This is some additional information I am sharing, that even if we are not provided with some such kind of the information that the instrument is moved after 3rd, 6th, 8th reading, we can easily work out where that particular, say, instrument shifts are and which points are change points. So the way you see here, 2.228, 1.606, and here the reading is, third reading is 0.988. That means fourth reading should have been entered as backside. Similarly, sixth reading will be foresight, whereas seventh reading will be backside. And the last station, 2.684. I hope there should not be any confusion. Some small thought to this will help you. So you have the reduced level. You can work out the HI by adding these two. Deduct 1.606, work out the RL. Deduct 0.98, work out the reduced level. Add 2.09 in this particular RL. Work out the HI newly developed, and as you continue the calculations, you will be able to calculate all these particular reduced levels. Here, lastly, apply the check. It will help you to understand whether you have done all that particular calculations properly or not. One more thing, as you work on site, you could be working on kilometers together. Hence, you will be making use of one simple page of the field book, which will be hardly accommodating some 10 to 12 entries. So at that time, you have to see that on each of the pages, you will be performing the calculations, you will be applying the checks, and after applying the check, then only switch over to the next page. Practically, this is very important. So same calculations are shown by rise and fall method also. So thank you very much friends for your attention. I hope the concepts that we discussed about the triple simple and differential leveling, their categories, the data entry, working out the reduced levels and apply the check is clear to you. So in the coming presentation, we'll discuss about profile leveling, cross-sectioning, and also will get introduced with reciprocal leveling. So by till then, I wish you very happy learning. Thank you.